Hello, grade 9s. We are now beginning chapter 9 entitled Linear Inequalities. Let's have a look at what this unit will involve. So there are 3 sections to this chapter. Section 1 is representing inequalities. Section 2 will be solving single-step inequalities. Then we'll have a quiz. And then section 3 is solving multi-step inequalities. There will be some time for review, and then there will be a unit test. Let's have a look at section 1, representing inequalities. So, there are some definitions to review, just to remember what you've learned previously. This symbol here means that A is greater than B. So it opens to the bigger value, which means if this one opens to the bigger value, that means that A is less than B. Now if we add a line underneath it, that means that the A is greater than or equal to B, and A is less than or equal to B on this one. And we can say that A is not equal to B by drawing a diagonal line through our equal sign. So A is not equal to B. Now there are 3 ways that you can show inequalities as indicated here. We can use words. So for example, all numbers less than or equal to 0.75. That's one way to use words. You can use diagrams or graphs. And here's an example using a number line. We've got 0.75 shown here, and it's filled in with a dot. That's to indicate that that's the end of the set of values that qualify. And then it's less than or equal to. So there's a dark line with an arrow shown highlighting to the left on the number line. So anything that's on this line is actually less than or equal to 0.75. Something we'll get to a little later on. You can actually use a circle on 0.75 if it means it's just less than 0.75, but less than or equal to, you actually color in that circle. And then you can use the mathematical symbols like we talked about over here on the left. For example, x is less than or equal to 0.75. So that's 3 ways to represent the exact same meaning. Now, working example number 1 for representing inequalities. A boundary point, and this is what I was just talking about, separates the values less than a number from the values greater than a number. An open circle shows the boundary point is not included in your solution. So in this case, this would be greater than 8. And a closed circle shows the boundary is included in the solution. So it's not less than 4.6, it's 4.6 equal to or less than 4.6. Here's a question. Rima earns overtime pay when she works more than 40 hours in a week. Just a little sub note here. Overtime pay is extra money that you're paid if you work longer than expected. Currently, if you work more than 40 hours in a week, I believe you get paid for extra hours at time and a half, so 1.5 times your hourly wage. So if you're making $10 an hour, then you get actually paid $15 an hour for any time that you work past that 40 hours. And it can also be calculated based on the length of shift. If you put in a long shift and then maybe some short ones, you might have less than 40 hours, but that long shift, which is over, I think it might be 8 hours. If you work a 10-hour shift, then that extra 2 hours at the end of your shift would actually get paid out at that time and a half as well. So that's what overtime pay is. But the 8 hours and the 40 hours has a tendency to change with government regulations, so that may not be current at the current time. When does Rima earn overtime pay? Give 4 possible values. Rima does or does not earn overtime pay if she works exactly 40 hours. So if she works 40 hours, then she does not, because we were told when she works more than 40, she gets it. Rima earns overtime pay if she works more than 40 hours. So if she works 40.5 hours, she earns overtime. If she works 42 hours, she gets overtime. If she works 50 hours, she gets overtime. If she works 60 hours, she still earns overtime pay on those hours. So it's anything more than 40 hours. To earn overtime pay, Rima needs to work more than 40 hours. We're going to show the inequality on a graph. So you can draw a number line and mark out a bunch of numbers on it that includes 40 somewhere in the middle. And you want to see values that are close to 40. So in this case, every second tick is 10, every one tick is 5, and that's fine. So 40 is your boundary point. Now, if she works 40 hours, she doesn't get overtime pay. So 40 itself is not included in overtime pay, so we're going to draw a circle on 40. And then anything bigger than that, we're going to shade it a little bit darker than the rest of the number line, and then have an arrow on the right. So this shows that anything over 40 hours will get overtime pay. So draw an open circle at 40 to show the boundary point, which has been done here for us. Starting at 40, draw the arrow to the right. This shows the possible hours are greater but not equal to 40. Now, write the inequality using algebra. Well, if T is the amount of time in hours that Rima works in 1 week, the inequality is T greater than 40. That will, if that's the case, then she will get overtime pay. What inequality shows the amount of time does not allow Rima to earn pay. So, the inequality where she does not earn overtime pay is 40 hours or less. So Rima does not earn overtime pay if she works less than or equal to 40 hours. To graph it, again, same number line, or a slightly different version is fine too. Boundary point goes at 40, and in this case it's a closed circle because if she works 40 hours then she does not get the overtime pay. And then you shade the arrow to the left. This shows you that values of T are less than or equal to 40. So let T equal the amount of time in hours that Rima works. So the inequality then in this case is T is less than or equal to 40. Okay, so now there's a show you know for you to do. Please go ahead and do that.